Hey Adam, I'm sorry I'm away today, but I've got a sick little boy. So what we're going to do is, instead of just giving you questions from the textbook, we're going to try and finish the activity we started last lesson so that you've got everything you need to continue on with next week. Now, at the very end of last lesson, I asked you guys to go to this new website, ptable.com. And on that website, you were asked to click the Properties tab. And from there you are asked to find the properties of aluminium and lead. So on ptable.com, this is what you'll be looking at. You needed to click this little tab here, make that a better colour, that little tab there right near Wikipedia, and after you click that, this little box will come up here for whatever element that you were looking at. Once you've done that, you can find aluminium and find lead and take a screenshot of each. So you end up with a screenshot of aluminium's properties and lead's properties. If you can't find lead, look for the symbol PB, because that's its chemical symbol. So I'm going to ask your teacher to pause the video and let you go to this properties tab in ptable.com and screenshot the properties of those two elements. Okay, now that you've screenshotted those two properties, I want you to open up Notability. Go to where we were last time. You need to start a new section where you're going to be inserting your screenshots of lead and aluminium into your Notability document, and you're also going to be drawing a table for me. So I'll give your teacher a few minutes to get you to open up Notability and input your screenshots underneath where we finished last. Okay, you should have by now inputted your screenshots into Notability. So you should have these in there now waiting for you. And I'm wanting you to draw up this table for me. I'll ask your teacher to pause the video so that you can do that now. Okay, now you've added in that table, you're going to be finding 4 properties on your screenshots and writing them in. These are the properties. You're going to be finding the melting point, the boiling point, the radius of the particle. That's a measure of the size of the particle. Yes, they're not all the same size. And the mass of the particle. Now this I'm going to show you right now where to find. The mass is not going to be listed as easily as the rest. If you go and have a look at your inserted screenshots, this is what you're looking for. Right here, underneath the name, there's a square here. This number is the mass. You need to use this number to fill in that last part of your table for aluminium and for lead. I'll get your teacher to give you a few minutes to go through and list those properties for aluminium and lead and draw them in the table for me. Okay, now in your table you should have something that looks like this. For aluminium, you should have melting point of 933, boiling point of 2792, radius is 118, and the mass is 26.981. Next door with lead, we actually have a melting point of 600, boiling point of 2022, radius is 154, and the mass is 207.2. Now you might notice that they're measuring the melting and boiling point with a letter that you don't actually know yet. K stands for Kelvin. That's the scientific way of measuring temperature. Whereas Celsius and Fahrenheit go below 0, so you have plus and minus 0 in Celsius and Fahrenheit. With Kelvin, we actually put 0 right at the very bottom point where you cannot go any further. So 0 Kelvin is where all the particles have absolutely no heat left in them whatsoever, and they have stopped vibrating altogether. That is 0 Kelvin. That's actually 273 degrees below 0 degrees Celsius. Okay, now that you've got those up, we're going to compare them. If you have a look at the radius and the mass, there's a few important things to know that are going to affect our picture that we draw of particles from now on. Whereas before you would have drawn, say, an aluminium and a lead particle exactly the same, you can actually see that their radius is completely different. In fact, the radius of lead is 30% bigger than the radius of aluminium. So it's much difference in size. Now, although he's only 30% bigger, that's a third, look at the difference in their mass. 8 times bigger. So 30% bigger in size, but 8 times or 800% bigger in mass. So that's certainly going to change the picture that we drew of all those particles exactly the same size, and at that point we thought all the same mass. Okay, now before we go any further, I'm not going to get you to redraw anything yet. I'm actually going to get you to go and watch a few clips that I've got on Connect. Your teacher should be able to find the links there. So could you help her get to Year 8 Science Connect for a moment? And there's going to be some YouTube and other links for you guys to explore. Watch the videos first, and then you guys are free to, if you have free time, you are free to go and explore the other links that I have below. Whatever you do, don't forget your homework. It is due Monday. It is on Connect. Now, the one thing is you haven't got your activity books back. There's only one page to do out of them. If you handed them in, make sure you collect them off my desk before you leave today. Okay? You guys have a great weekend. I'll see you later.